Hello everyone, good evening. Welcome back to Gate Wallah English YouTube channel. I hope everyone is doing great. So how you all are, kindly comment everyone, then we'll begin our classes. So before starting, everyone kindly comment that if I am fully audible and visible to you all, then we'll begin. Okay, good evening Sushil. I hope you are doing great. So in today's lecture, we are going to proceed with the remaining precipitation topics. I hope you all remember the last topics. Let's have a quick recap of all the things which we have discussed till now. After that, we'll proceed with the further topics. Tell me how you all are doing. Tell everyone, then we'll start. Good evening, everyone. Kindly comment that if I'm fully visible and audible to you all. So today we are going to basically continue with average depth of precipitation, because in the last class we have discussed the topic, namely average depth of precipitation. Okay, so in hydrology till now, what we have discussed, the things which we have discussed, the very first topic which is started was your how much water is present. Okay, why we are studying hydrology, what is hydrology, and what is our responsibility as an engineer. Okay, that we have discussed. Simply management of water resources we have to do. I have already told you this thing. Then we went on to discuss what is water cycle, how it is caused, and what are the different phases in the water cycle that we have discussed. Okay, namely evaporation, then precipitation. After that, all the losses takes place, after which your runoff happens. Okay, so it was a cycle. Then we went on to discuss global water distribution, how much amount of water is present in different phases that we have discussed. Okay, I hope you all remember that. After your discussion on global water distribution, we went on to discuss what is what is watershed, what is catchment area, what is basin. Okay, all these things we have discussed. We discussed about catchment leakage. Okay, when the groundwater divide and your surface divide are not coinciding, then leakage takes place. That we have also discussed. After this, one very important topic which we discussed, from which many questions are framed in your past year papers, that is your water budget. Okay, I hope you remember water budget. The basic equation. Can you tell me the equation? Can you kindly comment what is the water budget equation? Everyone try to comment. Okay, see, we have to participate. Participation is very important if you want to remember all the concepts in the class itself. Okay, I hope you are solving previous year questions simultaneously, because if you want to succeed, if you want to crack GATE or ESE in any or any civil engineering technical exam at once, then you have to practice a lot. Yes or no? So kindly participate. It's a humble request that you participate in all these sessions. Okay, so can you tell me what is the water budget equation that I told you? Can you tell me? Good evening, dear. Good evening, Ajay. Good evening. Okay. Yes, Kiran, you are saying precipitation minus losses equals to runoff. So this was the most, you can say, simplified version. Okay. But the important one, or you can say the starting one, was P minus R minus GET equals delta S. This I told you. After this delta G, delta S, I made it equal to 0, based on the assumptions on longer durations and if we have large catchment area. Then we went on to reduce our equation to P minus losses equal to change in storage. Yes, or simply runoff. Okay, whatever precipitation we have, out of that losses will happen, and whatever losses will happen after that, whatever water is left, that will take in the that will run off. Or you can say this is direct runoff or excess rainfall. We'll discuss these terms later. After water budget, we discussed about precipitation causes. I hope you remember. Okay, we went on to discuss the causes of precipitation. I hope you remember it. Okay, what were the causes of precipitation? Sir, the causes of precipitation was, sir, that humidity increased. Okay, whenever humidity will increase and temperature will go down, then, sir, precipitation will happen. I already told you this thing. Because, sir, whenever temperature goes down, the saturation vapor pressure, or you can say the moisture holding ability of atmosphere goes down. Yes or no? I hope you remember this. Okay, so causes we discussed. After causes, we went on to discuss the types. 4 types basically we discussed. The first one was your convective precipitation, in which, sir, we saw that air masses have different densities. Okay, because of heating effect of land masses, we see that lighter air is accumulated near the surface, which rises up, and convection currents are set up. Yes or no? I hope you remember that. Convective. Then after convective, sir, we went on to discuss about orographic, in which moisture laden winds were forced to move up. I hope you remember this. Okay, after your orographic, sir, we went on to discuss cyclonic, in which, sir, we have a low pressure zone, and wind was coming gushing into the low pressure zone and forms a circular winding motion. Yes or no? I hope you remember it. Okay, circular motion is known as your cyclone. In cyclone, sir, we have a low pressure region at the you can say, eye of the cyclone. Yes or no? Then after cyclone, sir, we went on to discuss frontal precipitation. So basically, sir, you told us about 4 types of precipitation. I hope you remember it. See, revision is very, very important. I know that revision is tough and you find too much of inertia in revising it. Okay, that's why only 5 minutes I take in the beginning of class. Okay, so that entire revision is complete. So after types, we went on to discuss forms of precipitation. I hope you remember the various forms of precipitation. And in forms of precipitation, the very first one, the most dominant precipitation which we saw on planet Earth. Can you tell me which one is that? Can you tell me which is the most dominant form of precipitation? Sir, the most dominant form of precipitation is rainfall. Yes or no? In which the drop size was ranging between 0.5 to 6 mm. And sir, we also classified it. Light rainfall was less than 2.5 mm per hour. Then moderate rainfall was there, in which, sir, we saw 2.5 to 7.5 mm per hour intensity is there. After that, we have heavy rainfall, in which we have intensity of rainfall even more than 7.5 mm per hour. Sir, then we went on to snow. Snow's average density is 0.1 gram per cc. I hope you remember it. Okay. And snow was, sir, opaque also. Snow was opaque. Then we have sleet, which is mixture of snow and rain. Yes or no? Sleet was mixture of snow and rain, but sir, that snow is transparent or translucent. Then sir, hailstorm was there, in which the size of ice plates was somewhere around 5 to 50 mm. Then we went on to drizzle. Drizzle was having intensity less than 1 centimeter per hour, and drizzle is having drop size even less than 0.5 mm. Okay, it's very, very small. Okay, minute drops generally falls in there. Then we have discussed glaze. Okay, so all the forms we discussed, after which we went on to measurement of precipitation. I hope you remember. Sir, in measurement, sir, you told us about 2 kinds of rain gauges. Okay, rain gauges, you can call it hytometer, pluviometer, ombrometer. All are one and the same. All are one and the same. Okay, I hope you remember that. Yes or no? Then, sir, you told us that in non-recording time. Can you tell me what is the most dominant non-recording rain gauge type of India that we use? Can you tell me? Everyone kindly comment. Everyone kindly comment the most, you can say, non-recording rain gauge of India. Kindly comment. Kindly comment if you remember it. Yes, perfect. Simon rain gauge. Yes, great. Simon rain gauge is the one which is being used in India. Yes, perfect. Yes. Then tell me the recording rain gauge which is standard recording rain gauge of India. Can you tell me the standard recording rain gauge of India? Yes, it is natural siphon type. Okay, in tipping bucket we have discussed weighing bucket type, then we have discussed natural siphon type. See, tipping bucket gives us intensity versus time graph. I hope you remember it, and it is used in hilly, remote and inaccessible areas because we receive signal in the lab itself. Yes or no? Then in weighing bucket and natural siphon, sir, we receive what kind of graph? Can you tell me which graph we receive in weighing bucket and natural siphon type? Kindly comment, everyone. Kindly comment which type of graph we receive. See, these are the questions which are framed in your question in your examination. Tell me the answer. Yes, mass curve is the one. Very good, Kiran. Very good, Sushil. Perfect. The graph which we get is mass curve. Perfect. Okay. After measurement, sir, we went on to like my data should be how data is prepared, how it is presented. Okay. I told you about normal precipitation, the average the average of which is taken in 30 years. Then I discuss about average annual rainfall. I hope you remember that. Okay. Average annual rainfall is basically for 35 years. How much is the average annual rainfall in India? Can you tell me? How much is the average annual rainfall in India? Can you tell me? Kindly comment. Average annual rainfall in India, how much it is? Kindly comment, everyone. Yes, perfect. Yes, 119 centimeter. Yes, you remember it. After that, I told you that my rainfall data should be continuous and consistent. Yes or no? And consistent data is made consistent with the help of 2 methods. Okay, I think those 2 methods are here or not? Yes. No, it's not here, but yes, still we solved some questions. I told you about estimation of missing data. Sir, in estimation of missing data, sir, you told us 2 methods, arithmetic mean method, and the second was normal ratio method. The first method, arithmetic mean method, was used when the selected stations normal were lying within the 10% of the normal precipitation value of the missing station. I hope you remember this. But if all the normals, if even one of the normals are going beyond 10% range of the normal precipitation of the missing station, then I will use which method? I will use normal ratio method. Okay, and I also made you to solve some questions with the help of which I hope the entire concept was clear to you. Okay, see, if these normals of selected stations are lying within, then I will use arithmetic mean, otherwise I will use normal ratio method. After this we went on to discuss about inconsistency. Can you name the technique which is used to discuss which is used to, you can say, remove the inconsistency of rainfall record? Can you tell me the name? Can you tell me the name of the technique with the help of which we remove inconsistency of rainfall record? Can you tell me the name? Yes or no? See, it's very important. The name at least you should remember. Okay, name was very, very important. Yes, double mass curve was a technique. Perfect. After which, yes. No, Tushar. The answer to your question is no, but yes, give your best in order to get selected in that one. So after that, we went on to discuss about average depth of precipitation. This was the last topic where we left. Okay. See, average depth of rainfall is required so that we can multiply it with the catchment area. If you will multiply average depth of rainfall by catchment area, you will get the volume of rainfall. That's why we were interested in that. Sir, you told us about the three methods. Two you told us in the last class. Today I will discuss the third one and then I will proceed with the next topic. So the very first one, which was, sir, least reliable. Sir, the method which was least reliable and least accurate was, kindly comment everyone, which was the least, you can say, which was the least reliable and least accurate method. Everyone kindly comment. See, why it is least reliable? Can you tell me? Sir, the arithmetic mean method is least reliable because, sir, this method is suitable for plain areas and when the rain gauge distribution is uniform. But in actual practice, sir, you will observe that no area is plain. Every area you will see, every catchment area you will see, it is undulated. It is uneven. Yes or no? Yes or no? Yes, it is uneven. And also you will notice that rain gauge distribution is more or less non-uniform. Never it is uniform. Okay, so practically neither you will find plain areas nor you will see that rain gauges are distributed uniformly, because of which arithmetic mean method is least reliable. Yes or no? And arithmetic mean method is very simple, sir. In this, sir, we have to simply take the average. Okay, I hope you have understood this. Then after this, which was the better method? The second method, Thyssen polygon method, was better than this, and many questions have been framed in past year papers regarding this topic. Okay, see, this method was better because it takes care of non-uniform distribution of rain gauges. Sir, if rain gauges are non-uniformly distributed, even then this method will work. But yes, sir, it is again suitable for plain areas. It is not suitable for undulated or hilly areas. Okay, wherever, sir, we have you can say undulated terrain, in that cases, sir, this method will fail. Yes or no? But yes, it is better because it is taking care of non-uniform distribution of rain gauge. Sir, how it is taking care? Now the question arises, sir, how it is taking care? I told you about this thing. Okay, sir, it is taking care because, sir, it has see, I told you about the steps. See, what were the steps? Sir, the very first thing, that we have to join these stations with the help of straight lines. Then we have to draw perpendicular bisector on each of the sides of the triangle which we have formed. Yes or no? Those bisectors are extended. This was the step 2, and they are extended to such an extent that Thyssen polygons are formed for each and every station. So each and every station is allocated a Thyssen polygon area, the area of which we can determine with the help of a meter known as planimeter. Remember this. Otherwise, mostly what we will see in GATE examination, the areas are given to us. Okay, mostly you will see that areas are given to us, or what you will see that you have a symmetric figure. Okay, you have a symmetric figure in which the areas can be evaluated or calculated. Okay, there we will not be using any kind of planimeter, but yes, if the area is irregular, you can see this area is irregular, so obviously we need planimeter in order to determine its area. And once we have found out the Thyssen polygon area, we will apply this formula Okay, corresponding station precipitation multiplied by its corresponding area, sum it up and divide by total area, you will get the average precipitation. Okay, see this area weightage thing, is actually taking care of the non-uniform distribution of rain gauge. Okay, yes or no? I told you this thing. Okay, I told you this thing, that this area weightage thing, because you have multiplied each and every precipitation. Listen very carefully. Okay, from this method only I am going to continue the third one, because in third one more thing we are going to modify. In the third method, sir, I am going to modify one more thing in this formula, so that it takes care of this undulations also, so that it takes care of hilly areas also. Yes or no? So what is that modification, that I am going to tell you. Okay, but sir, here I can assure you that because of this area weightage thing, um, see, some station acquires more area, some station acquires less Thyssen polygon area. The station which is acquiring the more, you can say, Thyssen polygon area is having more weightage, and the mean will be nearer to that value. The mean of precipitation will be nearer to that value. Yes or no? I hope this thing is very, very clear to you. Okay, after this we will move on to the third method, which is the best one. The third method is your isohydral method. We are going to discuss that. Okay, yes, so now we are going to discuss about the isohydral method. Okay, I told you about some questions. See, this is a regular figure, so obviously we discussed this question very beautifully. We have joined these stations in order to form the triangles. Then we have also bisected the sides. Okay, after bisecting the sides, sir, we went on to form the Thyssen polygons, and we have also evaluated the areas of Thyssen polygon. Yes or no? So I hope this is very, very clear to you. These type of question we have already solved. In some questions, sir, we are required to find the area. In some questions, sir, Thyssen polygon area is directly given to us. Okay, any kind of question can be asked in your examination, but yes, both the cases are possible. Okay, here also we have, see, in this question, Thyssen polygon areas are already given to us. Okay, so anything can happen. I told you about the significance, that if your station is lying outside the catchment area, or if it is lying within the catchment area. Okay, I hope you remember it. Now we are going to discuss about the third method, and in today's class basically we'll try to cover the third method and depth area duration curve, that is DAD curve. If time is left, we'll also move on to frequency of point rainfall. Okay sir, so today basically we are going to discuss, wait a second. Okay, the third slide is missing. Wait a second. Let me use the slide of isohydral one. Isohydral method slide is missing. It will be here in some seconds. Yes. Wait a second. So yes, now we are going to discuss the isohydral method. Okay, so isohydral method is the best one, this is for sure. Okay, but sir, how it is the best one? The thing is, sir, how this method is the best method in all the three methods? Okay, sir, you told me that the very first method, arithmetic mean, was more suitable for plain areas. Yes or no? Sir, the first method was more suitable for plain areas, and it was suitable when rain gauge distribution non-uniform. But now both the things will be taken care of if your area is even, undulated or hilly, then also this method will give you better answers. Okay, and if your rain gauges are non-uniform, then also this method will take care. Okay, so this method is the you can say the best method. Okay sir, but tell me how it takes care of non-uniform distribution rain gauge, and how it takes care of you can say topographical influences, because sir, you are saying that this method will take care of undulated or hilly areas. Even if your terrain is uneven, then this method will take care. But sir, how this is happening? Tell me that thing. Okay, so before starting further, let me tell you a logic. Okay, listen very carefully. I hope till now everything is very clear to you. Everyone kindly comment yes in the comment box so that I am able to understand that all the things which I am telling are fully clear to you all. Then I will proceed. Everyone kindly comment in the comment box yes or no. Okay, so here comes the logic. So let us assume that we have a hilly terrain. Okay, let us assume we have a hilly undulated terrain. Okay, so no issues in that. Let us say we have installed a rain gauge here and we have installed a rain gauge here. Okay, let us say we have installed two rain gauges, one at a higher elevation and one at a lower elevation. Okay, now tell me, just taking an example, let us assume the amount of rainfall, the depth of rainfall which is accumulated in this rain gauge is somewhere around 6 centimeter, and let us assume the amount of rainfall which is accumulated in this rain gauge, let us say it is 7 centimeter. See, one more thing you should remember, in an area, okay, let us say if it is receiving rainfall more or less uniformly, then you will see that the rain gauge which is at a higher elevation, listen very carefully, the rain gauge which is at a higher elevation will receive lower rainfall. Listen very carefully. Sir, the rain gauge which is at a higher elevation will receive lesser rainfall as compared to the rain gauge which is at a lower elevation. Okay, I think this thing is very clear to you. Now tell me one thing. If someone asks you like what is the average rainfall in this middle area, what is the average rainfall which is being received by this area, can you tell me the precipitation which is being received in this area will be? Can you tell me something by logic? Can you tell me how much is the rainfall, how much is the average rainfall that will be received by this middle area? Can you tell me? Kindly comment if you can guess it. Yes, you are saying yes, 6 plus 7 by 2 is the perfect answer. Great. So 6 plus 7 by 2 is the perfect answer. That means this area is receiving average rainfall of 6.5 centimeter. Yes. So this logic we are going to apply here. Okay, this logic we are going to apply here. So if we have hilly areas, then what I am going to do, I will draw two lines. Okay, let me explain this entire concept here. Okay, let me explain this entire concept here. So imagine we have a catchment area. Imagine we have a huge catchment area here, and let us say we also have certain stations. Imagine we have certain stations like this. Okay, assume that in this one rainfall is somewhere around 6.2, here rainfall is around 7.4, here it is 8.5, like that. Okay, like that. Here it is 9 and then here it is 10. That means, listen very carefully, that it is simply telling you that the elevation is going down, because when elevation goes down, listen very carefully, when elevation is decreasing, then only the rain gauges will receive more rainfall. So this will be at a lower elevation and this will be at a higher elevation. Okay, I hope you can understand this I have already told you. Okay, perfect, sir. Now what I am going to do is I am going to draw iso heights. Okay, I am going to draw iso heights. Sir, but tell me the meaning of iso heights first. Okay, what is iso heights? See, iso heights is comprised of two words. Yes or no? Iso heights is comprised of two words. The very first one is iso. Iso means same. Iso means same, and height means rainfall depth. Height means rainfall depth. Yes or no? Tell me. So we are going to draw some imaginary lines here on which all the points will have equal amount of rainfall depth. Listen very carefully. So I am going to draw some lines. Let me draw this line. Let me draw this line. Okay, so these are the lines. See, these lines can be drawn by some experienced person. Not anyone can draw this line. Okay, these lines are known as iso heights. Okay, what is the speciality of these lines? So listen very carefully. On these lines, sir, what will happen? On these lines, we have same amount of rainfall. Imagine, see, this line will be having, let us say, rainfall of 6 centimeter. This line will have rainfall of, let us say, 7 centimeter. Why? Because 6.2, in between 6.2 and 7.4, we will have a line of 7. Yes or no? In between 7.4 and 8.5, we will have a line of 8 centimeter. Like this. Okay, like this, by pattern, or you can say by experience, you will be able to draw the isohydral map correctly. Yes or no? Yes or no? See, this isohydral map drawing is a cumbersome and difficult task. It is not easy and it cannot be done by anyone. Some experienced meteorologist will be able to draw this kind of isohydral map. Yes or no? So I am simply saying that these isohydral maps are not easy to draw. Okay, these are not easy to draw. So, but let us assume that at the end we have some isohydral map. Okay, let us assume that on this line the rainfall is P0. Let us assume on this line the amount of rainfall depth is P1. Let us assume on this line the amount of rainfall is P2. Let us assume on this line the amount of rainfall is P3, and so on so forth. Okay, on this line let us assume it is P4 and then it is P5 here. Okay, perfect. Now here you can see, because of these isohydral lines, see on this line, if you will see any point, on this line, if you will see any point, all the points, sir, all the points will have same amount of rainfall. All the points will have same amount of rainfall. That is the meaning of isoheight. Yes or no? Let me write the meaning of isoheight here. An imaginary line, isoheight, sir, it is an imaginary line, sir, which is joining points of equal rainfall, I hope this is very clear to you. So on this entire line the depth of rainfall is P0. On this entire line the depth of rainfall is P1. Okay, and in between, acha, tell me what will be the depth of precipitation in between? Obviously, sir, P0 plus P1 upon 2. What will be the depth of precipitation in this area? Sir, the depth of precipitation in this area will be P1 plus P2 upon 2. Okay. Sir, what will be the depth of irrigation in this area? Sir, it will be P2 plus P3 upon 2. I hope this is clear. Yes or no? Perfect. Now, can you tell me the formula? Can you tell me the what is the formula for P average? Sir, what is the formula behind P average? Yes or no? So, if I am using isohydral method, the formula for P average is, can you tell me? So imagine this area is A1. Imagine this area which is between P1 and P2 is A2. Okay, let us say this is A3. Let us say this is area 4. Let us say this is area 5, like this. Okay, like this we have different areas. So can you tell me what is the area weightage thing of this first area? See, can you tell me? See, whatever is the area which is coming between P0 and P1 is receiving an average rainfall of P0 plus P1 upon 2. Yes or no? Sir, whatever the area is coming between this P0 and P1 is receiving average rainfall of P0 plus P1 upon 2. Simple. Yes or no? Sir, the area which is coming between these two lines are receiving average rainfall of P0 plus P1 upon 2. So this average thing, listen very carefully, sir, this average thing is taking care of the topographical influences. See, if this area was uniform, listen, sir, you are saying that if this area was uniform, see, in the last methods what we did basically, wait a second, in the last methods I told you, wait a second, let me delete some slides first. Let me delete these slides. Yes, so what I was saying here, that what I was saying was, yes, in the last methods the Thyssen polygon one, sir, in that, sir, you have taken uh, plane areas. You have simply multiplied the area by direct precipitation of rain gauge. But sir, here what we are doing, we are taking average. That's why it is taking care of the areas which are not plane. Okay, that's why isohydral method is taking care of those areas which are not plane. If the areas are not plane, they are undulated, they are hilly. Okay, and if you want to take care of all the topographical influences, sir, then I am going to use your isohydral method. Okay, so can you tell me what is the average rainfall that is being received by area A1? Sir, we can surely tell that, because here, sir, you can say that the average rainfall which is being received by area 1 is none other than P0 plus P1 upon 2 multiplied by its area. So what is the difference between Thyssen polygon method and this one? See, the basic difference is that here we have taken average of rainfall. Okay, here we have taken average of rainfall. I hope this thing is very clear to you. Yes or no? Sushil, Manjusha, Ajay, I hope this is very clear to you. Okay, so sir, what we have done here is, sir, we have taken average of rainfall. Now tell me what is the rainfall that is being received by area 2. Sir, in area 2 I can say the average rainfall is P1 plus P2 upon 2. So I will sum it up. P1 plus P2 upon 2 multiplied by your total area. Yes or no? Similarly, I will do it for the third area. Third area is receiving average annual rainfall of P2 plus P3 upon 2 into A3 and so on so forth. So likewise we can continue, and whatever areas we are getting, we can take the isohydral average of simply the precipitations. Okay, now divided by the total area, which is none other than A1 plus A2 plus A3 plus A4 plus A5. Okay, that will give me the total catchment area. So this is the general average formula. If I am going to write in summation term, it will be from I equal to 1 to n. Okay, or simply you can say I is going from 0 to, okay, I will start from 0 to, no, I will write from 1 to n. So what I'm going to do here is pi plus 1 upon 2 general precipitation multiplied by the area. See, if this is P0 P1, okay, multiplied by general area I, like this, you will get the precipitation multiplied divided by the total area, divided by the total area, like this. Okay, so this is your general formula which you can remember from here. This is the general formula which we can remember. See, what is the difference between this method and Thyssen polygon method? Sir, the only difference is that we have not taken the precipitation directly as that of rain gauge. Simple difference. Sir, we have done what? The difference is that we have taken average of precipitations here between two isopluvial lines. Yes or no? So this term, because of this term, sir, you need to understand this method is taking care of topographical influences. Yes or no? Sir, this method, sir, for sure, this method takes care of topographical influences. Sir, for sure, this method takes care of topographical influences. Yes or no? So I hope this is very clear to you. That's why this method is best and it is suitable for undulated and hilly areas. Okay, remember this formula. This is very important. We can also solve one question. And since area weightage is there, we are dividing it into different areas. That's why it is taking care of non-uniform distribution of rain gauge. So whenever you will see in formula area term is there, non-uniform distribution of rain gauge will be taken care of, and whenever precipitation average will be taken, in that case topographical influences will be taken care of. Okay, so sir, we have seen Thyssen polygon area method. In that, sir, we have seen Thyssen polygon area method. Sir, in this method, sir, what is there? Sir, in this method I can see that no precipitation average there. That's why it is not taking care of the topographical influences. It is not taking care of the undulated and hilly areas. Okay. But since area thing is there, that's why it is taking care of non-uniform distribution of rain gauge. But in the last method, the basic arithmetic mean method, sir, neither there is precipitation average, okay, neither area term is there. If area term is not there, that's why it will not take care of the rain gauge distribution, okay. And since precipitation average is not there, that's why it will not take care of the topographical influences. So arithmetic mean does not take care of topographical influences, okay, and nor it takes care of your non-uniform distribution of rain gauge, okay. But since area term is introduced in your Thiessen polygon, so it will take care of non-uniform distribution of rain gauge, and since precipitation average term is introduced in your isohydral method, it will take care of sir, it will take care of topographical influences. Yes or no? I hope this method is very, very clear to you. Now we'll solve some questions and we will also highlight like what are the limitations and drawbacks of uh, isohydral method. In mains examination, in engineering services mains examinations, once this question has been asked, like what are the drawbacks, what are the limitations of isohydral method, okay, so those we have to discuss, but we'll discuss it later. First we will solve one numerical which is based on your isohydrals, okay. So try to solve this numerical, okay. I'm giving you 1 or 2 minutes time. Everyone try to solve this one. Let me see how many of you are getting the correct answer. Here we are seeing different iso heights are given to us, and the area which is being enclosed by these two lines is also given to you in the adjoining list or column. So find the average precipitation using isohydral method. Can you do this? Can you do this on your own? Such types of question can be framed in your examination, so try to solve it. Try to solve it. I'm giving you some time. Everyone like the session. Thank you, dear. Thank you. You are seeing RCC lecture. Great. Yes, I have tried to cover all the topics. I have tried to cover all the topics in there. So I hope you have liked it. Okay. So what we have to do basically here is simply apply the formula here. We will simply apply the formula. Wait a second. Yes, we will simply apply this formula. P average is P naught plus P1 upon 2 into area 1 and so on so forth like this, okay. Divided by the total area. So this we have to okay, so this is P average now. So the very first isohydral is 75 plus 85 upon 2. So we'll put it here. 70 will also put it from the starting so that it is covered in one line. So 75 plus 85 upon 2 multiplied by the area, which is 1600, plus 85 plus 95 upon 2, plus 85 plus 95 upon 2, divided by 3000, multiplied by 3000, plus 95 plus how much is there, 105. See, every gap is not of 10. Here we have a gap of 20 also. Okay, 95 plus 105 by 2, then we have a gap of 105 plus 115, I guess. Okay, let me check here. 2800, 1000. This area is 2800, this is 1000. Tell me how much you are getting if you have solved it already. Okay, can you tell me how much you are getting? Plus, wait a second, plus 115 multiplied by 900. Last term is left. Last term is 135 into 700, plus 135 plus 155 divided by 2 into 700, divided by the total area. Area is 1600 plus 3000 plus 2800 plus 1000 plus 900 plus 700. Okay, so how much is the average depth which you are getting here? How much is the average depth which you are getting here? You are saying it, Kiran is saying it to be 100.05, 100.2. Everyone try to give one kind of answer so that I am also able to write it. 100.2 I think is the correct answer, but let me check it. 80 multiplied by 1600, then 90 multiplied by 3000, then 100 multiplied by 2800, then 110 multiplied by 1000, then 125 multiplied by 900. At last we have 145 multiplied by 700, divided by 1600 plus 3000 plus 2800 plus 1000 plus 900 plus 700. So we are getting it as, yes, 100.2 is the correct answer. Great, Kiran. 100.2 is the correct answer here. So those who are getting your answer as 100.2. See, if we talk of numerator, the unit is, in numerator we have, see, this is in mm, I guess. This is in mm, this is in kilometer square. So in numerator you will have unit as, let me say this is in centimeter, let me say this is in millimeters. So millimeter multiplied by area, which is in kilometer square, and in denominator you have area. In denominator you have area which is in kilometer square, so it will get cancelled. The unit will be in mm. Okay, that's why I have written here in mm. I hope this is very clear to you. So precipitation is 100.2. So this kind of questions you can easily solve, yes or no? I hope solving such type of questions is very easy for you all, yes or no? Okay, not too tough. These questions are not too tough. I hope it is clear. Perfect. After this we'll proceed to the topic like what are the drawbacks of your isohydro method. We will discuss that in detail. So there are basically one or two drawbacks here also. I will discuss the drawbacks here. Wait a second. I will discuss all the drawbacks here. See, basically what drawback we have is, yes, now we'll discuss the drawbacks of this isohydral method. See, one thing is, this map which we have prepared is known as isohydral map. Okay, this map is known as isohydral map. Okay sir, this map is known as isohydral map. Now the thing is, drawing such kind of map is not easy, and it cannot be drawn by anyone. It requires skilled labor. So I can say, and also it will take too much of time. Okay, so I will say that it is time consuming. The very first limitation of this ISO, see, though it is the best method, but it will take time. So I will say the very first point is it is time consuming. It is time consuming method, and preparation of such kind of isohydral map requires experience. Okay, it requires skilled or trained personnel. Okay, skilled personnel. It requires skilled personnel to draw. It requires skilled, you can say skilled personnel or labor, you can write. Okay, skilled person. It requires a skilled person to draw isohydral map. And one more drawback, the biggest drawback is that we have to draw such kind of isohydral maps again and again. Why? Because rainfall pattern changes. See, whenever rainfall pattern will change, you have to draw map again and again. So this is a tedious process. This is a cumbersome and you can say tiring process, because we have to draw the map again. Sir, today first day, so should I attend starting lecture? Yes, you can attend the lectures from starting. Okay. Quickly try to finish all the lectures which are already there in a fast track mode. Then you can come live. Yes or no? But I am sure that you will like it and you will understand all the concepts in great detail. Okay, sir. So you are saying that these maps have to be drawn again and again if rainfall pattern changes. So these isohydral maps have to be drawn. These isohydral maps have to be drawn. Okay, have to be drawn again if rainfall pattern changes with time. If rainfall pattern changes with time. That's why we can say it's a tedious process. Okay, it is difficult and cumbersome method. Why? Because sir, we have to draw isohydral map, which is not easy. It is difficult and cumbersome process. So these are some drawbacks. But yes, if we are following a difficult process, then obviously the results which we are going to get will be more reliable. The most reliable answers which you get are from isohydral method only. Yes or no? Yes or no? I hope this thing is very, very clear to you. Perfect. So the best answers which you get are from isohydral methods only. So here we have completed all the three methods which are required to evaluate the average depth of precipitation. See, also let me tell you, isohydral method questions have not been framed much in examinations, but yes, some questions are there. But if someone asks me like which is the most important method out of all these three, then I will for sure say that Thyssen polygon method is the most important one. Okay, Thyssen polygon method is the most important one which has been asked in your examinations. Okay, now we'll move on to the next topic. Everyone try to revise Thyssen polygon method first, because it's the most important method which has been you can say frequently asked or regularly asked in your examination. Okay, so Thyssen polygon method is the most important one. Remember this thing. Now we'll discuss the next topic, which is none other than your DAD curve. Okay, like what DAD curve is, that we are going to discuss now. Okay, we are going to discuss what is DAD curve. So this is our next topic. Okay, great. So tell me if average depth of precipitation is fully clear to you, because that is very, very important topic. Now see, DAD, what does this signify? See, DAD in these three letters, the meaning of these three letters is the first D stands for depth, second A stands for area, and third D stands for your duration. Okay, these are your depth, area, duration curves. These are your depth, area, duration curves. Okay, I hope this thing is very clear to you. Now sir, tell me what is the significance of this? Okay sir, what is the significance of your depth area thing? Okay, I want to understand that. See, let me write here the meaning of these depth area curves. Okay, the very first point is it is depth, area, duration curve. Okay, it is depth, area, duration curve. So sir, tell me the meaning now. Sir, tell me the meaning. What is the meaning of depth area duration curve? Why it is drawn? Okay, how it is drawn? All these things we have to understand first. So see, one thing is that these depth area duration curves gives you the areal distribution. This gives you the areal distribution. Listen very carefully. See, this point has been asked in your state examination. So listen very carefully. The areal distribution characteristics of any storm. Okay, the areal distribution characteristics of a storm will be indicated by this DAD curve, because see, listen very carefully. If we have a storm of any given duration, let us say 1 hour, 2 hour, 3 hour, so the depth which it will acquire for a given area will be represented by this DAD curve. How? That I am going to tell you, but first let me complete this statement. So the areal distribution characteristics of a storm for a given duration, the storm is of a given duration, let us say 1 hour, 2 hour, 3 hour, like that. The areal distribution characteristics of a storm for a given duration is reflected by this depth area relationship. Sir, you are saying that we have three parameters here. Listen very carefully. Sir, we have three parameters here: depth, area, and duration. Three are there: depth, area, and duration. But you are saying that duration is constant. Okay, sir, now you are saying that duration is constant. Sir, if duration is constant, listen very carefully. Sir, we have three parameters here. If duration is constant, then how depth and area will change? If I am increasing the area, how depth will change? That I want to know if duration is constant. Okay, listen very carefully here. I will fully clear it, but you have to stay focused. Okay, so now sir, you are saying that we are going to focus on depth area relationship. You are saying that we are going to understand the depth area relationship. Okay, but for sure you are saying that duration is constant in this one. So what we can observe here is that, see, I am going to ask one question from you all. Listen very carefully. Let us say we have two areas. Okay, let us say we have area A1 and we have area A2. Okay, suppose that area A1 is large and suppose that area A2 is a smaller area. Okay, can you tell me if we are tell me one question I am asking you. If we are let us say rainfall is there in both these areas, same kind of rainfall which is giving you the same volume of rainfall. Okay, let us say same kind of rainfall has happened in both these areas A1 and A2. So can you tell me where the depth will be more? Can you tell me in which area we will have more depth of water if the volume of rainfall is same in both of these areas? Can you tell me where we have more depth of water? Yes, perfect answer. Yes, we will have more depth of water in area 2 because here sir, area we will have more depth of water here because area is less. Perfect, because area is less. So if area is less, depth is more. But if vice versa, if we talk of, we can understand that if area is more, then the depth is less. See, one thing is for sure, let us say this is D1. See, A1 into D1 is volume. Here we have A2 into D2. This is D2. Okay. So if we want to equate it, if area 1 is less, okay, if area, so sorry, area 1 is more. If area 1 is more, then depth has to be less. And if area 2 is less, then depth has to be more. So that the product of both of them are same. So that the product of both of these terms are same. I hope this is very, very clear to you, not so tough. Okay, all are able to assume it. All are able to guess it properly. Yes, Kiran, Ajay and Sushil, you are absolutely guessing it correctly. So one thing is for sure, but yes, one thing is for sure that depth is inversely related to area. Yes or no? Sir, you are saying that depth is inversely related to area. So if we have a bigger area, sir, if we have a bigger area, sir, if we have a bigger area, sir, you are saying that depth stored there will be less. Okay, but sir, one thing is very important in when we are comparing depth and area, sir, duration has to be constant. This is very important. Sir, in this case, duration has to be constant. Duration has to be constant. Okay, so sir, you are saying that we have two areas, one is big area, one is small area. In both of them we have 2 hour rainfall. Sir, we can compare only when duration of rainfall is constant. Okay, when duration of rainfall is constant. So this is important. Okay, see, we have some empirical relationships also. We have some empirical relationships also. How questions have been framed in exam, I will tell you later. But first, let us focus here. So what is the basic thing which you have understood here? That average depth decrease. The thing which you have understood from here is that the average depth, the thing which you have understood from here is that the average depth decrease, that the average depth decrease with the area. Yes or no? If area increases, depth is increased in an, and that too in an exponential manner, and that too in an exponential, and that too in an exponential manner, that too in an exponential manner for given duration. For given duration. Okay, now P average is given by P naught e power minus k a power n. So this is the equation with the help of, see, this is empirical equation. This is an empirical equation with the help of which we are simply going to put area and we are going to get average depth. Put the area here, get the average depth here. But yes, you can see that if area is increased, then depth will go down. These are the empirical relations which are being provided by some scientists. Okay, so this is also an equation which has been given in your sandbooks. You can understand it from here. Okay, now what is this P bar? P bar is nothing but your average depth of rainfall. It is nothing but average depth of rainfall in that, and that too in centimeter. Okay, what is P naught? P naught is highest amount of rainfall at storm center. P naught is highest amount of rainfall at storm center. Okay, this is P naught. What is K? K and N are constants. Okay, K and N are constants, and A is nothing but your area, and that too in kilometer square. Okay, put the area in kilometer square and get the average depth. K and N are constants. Let me write here. K and N are the constants depending on the region, what kind of catchment area you are having. Okay, on that K and N depends. I hope this is clear till here. Yes or no? Okay, so this is your depth area concept, but duration is left now. So what I'm saying here is simply, what I'm saying here is, if you are going to draw precipitation and area on a graph, tell me, here we have average depth, here we have average depth, and here we have area. So if area will decrease, can you tell me how this graph will go? Sir, obviously this graph has to decrease, sir, because you have told it many a times that when area will increase, graph will go down. This is the basic logic, and some scientists have also figured out the equation. Okay, some scientists have also figured out the equation. So they are saying that when your area is increasing, this this average depth thing will go down. Okay, this will draw on the next slide so that it will be more clear to you all. So this is important. Sir, when will irrigation start? Okay, irrigation, I can not tell exactly like when irrigation will start, but yes, chances are there that it will start after hydrology, but not for sure. Okay, it depends on availability of different teachers. So sir, you are saying, sir, you are saying that wait a second, let me draw some graphs here. I will draw the graph of your depth versus area. We will draw some graphs of depth versus area. Here we have area, that too in kilometer square. Okay, typical DAD curves look like this, that you have to remember. You have to know the shape. Okay, you have to remember it. Here we have maximum depth. Here we have maximum depth. These are our typical DAD curves. Okay, basic DAD curves will be looking like this. But yes, sir, one thing is there, sir, you have understood the relationship between depth and area. Okay, sir, you have understood the relationship between depth and area for constant duration. Sir, here three parameters are there. Wait a second. Sir, here three parameters are there: depth, area, and duration. Sir, duration is constant, and you have explained us the relationship between depth and area. But now we are going to understand the relationship between depth and duration for constant area. Okay, how depth and duration are related to each other. So can you guess? Let us imagine we have constant area. Okay, both areas are same. Imagine both areas are same. But here in the first case, we have a rainfall which is lasting for 3 hours. And let us say here we have a rainfall which is lasting for 8 hours. So can you tell me where the depth of precipitation or where the depth of rainfall will be more? Can you guess it? Where the depth of precipitation will be more? In the first case or in the second case? Can you tell me? Guess it. Try to guess it. Where you will have more depth of precipitation. Where you will have it? Yes, second case. Very good, Kiran and Manjusha. Why in the second case, sir? Because when more duration is there, the more depth of precipitation will accumulate. Yes or no? If more depth is there, obviously, if more depth is there, then obviously, sir, you are right. If more duration is there, sorry. If rainfall is happening for more duration, sir, I will see more depth is there. Here only for 3 hours, we will have less depth. Okay. So, sir, you are saying that depth and duration are proportional to each other. Okay, this is the second logic which you have to remember from here. Okay, depth and duration are proportional. If duration of rainfall will increase, sir, then for sure depth of rainfall will also increase. That you have already told me. Okay, by your own logic you have told this thing. But yes, sir, whenever we are going to compare duration and depth, in that case I have to make area constant. Yes or no? Let me write here in the bracket that area is a constant thing here. Okay, so when your area is fixed, depth and duration are, see, I already told you that here we have three parameters. If we are going to study the relationship between depth and duration, then area has to be constant. But when we are going to study the relationship between depth and area, then duration has to be constant. Yes or no? Then duration has to be constant. I hope this thing is very, very clear to you. Yes or no? Here we have duration constant, here we have area constant. Let me write it with the same ink so that it gives you a better impact when you read the notes. Okay, here we have area constant. Sir, I have understood this concept entirely. So I was telling about you the shape of typical DAD curves, how these curves generally look like, that I'm going to draw here. Okay, see, we are going to draw these curves for particular duration. Let us assume the duration of rainfall is fixed and let us assume it to be 1 hour. Okay, so let us say duration of rainfall is 1 hour and that is fixed. Let us say we have only 1 hour rainfall but on different areas. Sometimes we have 100 kilometer square area, sometimes we have a 200 kilometer square area. But what we will observe basically, that when area is increasing from 10 hectare to 100 hectare to 200 hectare, when this area will increase, sir, what I will see? I will see that depth is decreasing. What I will observe, sir, basically, that depth will decrease. Yes or no? And you need to understand that on this entire graph, when we are increasing the area, when this maximum depth is increasing, you need to understand one thing, that duration is constant on this entire line. Okay, duration is 1 hour. We have assumed that duration of rainfall is constant. So here on this graph, we can clearly understand this relationship of depth and area thing. Let us say we have 6 hour duration. Let us say we have 6 hour duration. So the graph will go like this. Again, it will go like this. Okay. So this is for 6 hour duration. When we have 6 hour duration, the graph will be like this. Let us say we have 12 hour duration. Let us say we have 12 hour duration. So the graph will be like this. It is 12 hour duration depth area graph. Okay. So what we can infer from here? We can see that the shape of these graphs. Can you tell me the shape of these graphs from outside? From the upward side? Can you tell me the shape? Can you tell me the shape? See, in examination, the shape of these DAD curves have been asked. Okay, so you have to remember it. See, this curve, when you will see it from the upper side, it is convex in nature. And from the downward side, it is concave. This is convex, or this is concave. Convex, I hope you all know. Okay, the side on which you can store nothing is convex, and the side in which you can store anything is concave. Okay, like this you can understand. Cave is a kind of place where you can store something. Okay, so from bottom side, from downward side, it is concave, and from upper side, it is convex. I hope this thing is very, very clear to you. So you have to remember this. Also, sir, one thing I am unable to understand, sir, why you have written maximum depth here? Why you have written maximum depth here? Because you need to understand we are always interested in finding the maximum depth. Tell me, if you are going to design, tell me one thing I'm asking you. Let us imagine we have a river. Okay, let us imagine we have a river, and on that river I am going to design a bridge. Okay, imagine it. Simply imagine that uh, on a certain river we are going to design a bridge. So obviously for that bridge, if we want to make it sure that that bridge never fails, or any kind of hydraulic structure you can imagine a bridge, you can imagine a culvert or a dam, okay, or a weir or a barrage, any kind of structure. If you imagine, you have to make sure that the highest amount of flood, highest amount of discharge that this river can carry, okay, that this river can carry, will cause no damage to our hydraulic structure that is built on that river. Yes or no? When we have maximum depth of rainfall, let us say for 1 hour, for 6 hours, for 12 hours, even in that case, my bridge, my hydraulic structure does not fail. So whenever I want to ensure safety to my hydraulic structure, whenever I want that my hydraulic structure is perfectly safe, obviously in that case I will design it for maximum depth of rainfall, because that maximum depth of rainfall will give you the maximum discharge in the river. Yes or no? Sir, whenever we are going to design any kind of structure, in that case we are requiring the maximum depth only. We are interested in the highest amount of rainfall. Yes or no? I think this concept is clear to you. Very simple. Basic logic is there. Let me write this point because this point is very important. Okay, this point is very important. So let me write this point here, that why, sir, we are interested in finding the maximum amount of depth. So why we are interested in the maximum discharge of river? Okay, because whenever design we have to do, we have to make sure that my design is safe for the highest parameters. If maximum rainfall is being tackled by our hydraulic structure, then whatever depth which is happening below this maximum depth, that will be also safe. Yes or no? For that case it will be also safe. Yes or no? So have you understood this thing? Have you understood this thing? Yes or no? Kindly comment once. Have you understood this logic? Why we are interested in finding the maximum depth? Okay, that's why these curves are sometimes known as maximizing envelopes. That's why sometimes these curves are also known as maximizing envelopes. Why maximizing envelopes? Because, sir, for 12-hour duration, and let us say for any kind of area, this is the maximum depth of rotation that will happen. That's why sometimes these curves are also called as maximizing envelopes, because in 12 hour no amount of rainfall can be greater than this, that we are assuring. Yes or no? So let me write this line which I have explained it to you right now. I will write here one thing, that it is it is necessary to have information of it is necessary to have sir it is necessary to have information of maximum amount of rainfall. It is necessary to have information of maximum it is necessary to have information of maximum amount of rainfall of various durations such as 1 hour, 6 hour, 12 hour, like that. Okay, so it is necessary to have information of maximum amount of rainfall of various duration on various sizes of areas on various sizes of of various durations such as 1 hour, 6 hour, 12 hour, like that, occurring over various sizes of areas, like this. Okay, so let us imagine, if I want to understand what is the maximum depth in our area if rainfall is for 1 hour and area is 100 hectare. So from these curves we are simply going to read out the maximum depth of precipitation. So these curves are helpful in these cases. Okay, so whenever we require that in what kind of let us say we have this kind of area and this kind of duration of rainfall, then what is the maximum depth, from these curves we can simply identify for design of different kind of hydraulic structures. Okay, for different kind of hydraulic structures, etc. Okay, so this you have to remember. Now one more point is important, sir. You are saying these envelopes which you have drawn here, these curves or envelopes which you have drawn here, are maximizing envelopes. Okay, why maximizing this? Because this will give you the maximum depth. Okay, these are your maximizing envelopes. These are, let me write here. Okay, don't worry, this will be the last topic which we are discussing today. I know it's late, but no worries. Yes, these are maximizing envelopes whose shape is concave upwards. See, convex upwards, sorry. From upwards, if you will see what is the shape, can you tell me? Kindly comment, everyone. Kindly comment. What is the shape when you see it from upwards? Everyone kindly comment. Everyone kindly comment. See, this is very important. What is the shape when you see it from upward? This can be asked. Okay. whenever we are moving outwards, we are moving outwards, the shape which we have on the outward side is convex. Yes or no? And also sir, we can appreciate the fact that duration is also increasing outward side. Okay, so let me write, see what is the meaning of maximizing. Maximizing means we are interested in the maximum amount of rainfall. Okay, so no matter what, whenever we have 12-hour rainfall, the precipitation value can never be greater than this value for this given area. Okay, so these envelopes are basically known as maximum envelopes, because whatever rainfall will happen will be lesser, will give you lesser value than this precipitation. Yes or no? Whatever rainfall will happen, that will give you the lesser value from these maximum values. Okay, so these are your maximum values. These are the maximizing envelopes. These are the maximizing envelopes which will give you the maximum value. No matter what happens, the value of rainfall will be less than these values. So these are convex upwards, sorry. These are maximum envelopes which are convex upwards, with duration increasing, outwards, So whenever we are moving outwards, duration is increasing. Here on this graph we have 1 hour duration, here on this graph we have 6 hour duration, here on this graph we have 12-hour duration, like this. So whenever we are moving outwards, duration of these graphs are increasing continuously. So you have to remember this. Okay, so one thing, sir, we have understood clearly from this typical DAD curve, like whenever we have constant area. Okay, sir, whenever area is constant, sir, here we have made the area constant. So whenever area is constant, I can see that duration is increasing from 1 hour to 6 hour to 12 hour. So whenever area is constant, and if I am increasing the duration, the depth is increasing. Yes or no? You can see from this graph. And when duration is constant on this entire line, I can see that with increasing area, we have less depth. Okay, so both the logics, I think, are very, very clear to you. If both the logics are very, very clear to you, how depth and duration are related to each other and how depth and area are related to each other, I hope this will give you full confidence in your DAD curve topic. Okay, so I hope both these logics are very, very clear to you. How depth and area are related to each other when duration is constant, and how depth and duration are related to each other when area is constant. Are both these things clear to you all? If it is clear to you all, kindly comment yes. And the shape of this curve is also very, very important. Okay, Sushil is saying, can we call it a summit curve? See, it's a kind of summit curve. See, summit curve is basically in your highways. Okay, summit curve is a curve on which basically you will see that basically vehicles and passenger vehicles and all the transport happens on summit curves. Basically it's a kind of curve on which your vehicular movement is there, but this is not a kind of summit curve is basically referred in your highway. Yes, it's a kind of summit curve, we can say it's a kind of summit curve because it is convex in nature from upward side. Yes, so it's a kind of summit curve, but yes, exactly we'll not call it. We have to differentiate between DAD curve and that summit curve which we study in your highway. Okay, so we have to differentiate between it, but yes, it's a summit curve, but obviously on this vehicles will not travel. Yes or no? So I hope this DAD curve concept is very, very clear to you. Okay, methods are also there in order to plot these depth area duration curve, but obviously those are not important. You have to remember this. Okay, let me tell you what kind of questions have been framed in examination. Okay, they will ask you such type of questions. Let me ask you one question, after that we'll end our class. So let me check if you are able to understand this or not. Okay, so I hope you are ready for the question. So the question which can be asked from this topic is like this. Okay, so we have a question. Let us say a statement is saying, in a catchment area of 100 hectare, for 3-hour duration rainfall, in a catchment area of 100 hectare for a 3-hour duration rainfall, the depth of rainfall is the depth of rainfall is 15 centimeter. Okay, 15 centimeter. So this is the first statement. In 100 hectare area for 3 hour duration, okay, for 3 hour duration rainfall, the depth of rainfall is 15 centimeters. So depth is there, duration is there, area is there. Now for same area, for same area, for same area, if 6 hour rainfall happens, 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 the depth of rainfall will be, the depth of rainfall will be, and three options will be given to you. ABC, three options are there. First option is equal to 15 centimeter. Second option is less than 15 centimeter. C option is greater than 15 centimeter. And D option is none. So can you guess the answer here? Can you guess the answer? If you are able to guess the answer here, I will understand that you have got the concept. Can you tell me what is the answer here? Kiran, Ajay, Sushil, everyone try to guess the answer here. In 100 hectare area, for 3 hour duration rainfall, we have depth of rainfall as 15 centimeter. Yes, Sushil, perfect. It will be more than 15. So you have clearly understood the concept here. So if such kind of questions are there in examination, I hope you will be easily able to solve it. Okay. Like this, 15 centimeter. So this is the first kind of question. Here you can see that area is same, duration has increased. So this logic we are applying. In this question, we are applying this logic where area is constant, but duration is increasing. Okay. And second kind of question can be, tell me if I am going to change certain data in this question. Let us say, now, let us say duration is same. Both times we have 3 hour duration. In first case, we have 100 hectare area, but in second case, let us assume, we have 150 hectare area. So now tell me what will be the answer. Now duration is same. Now duration is same, but area has increased. So now can you tell me what will be the answer? Now tell me ABC. Now tell me what will be the answer. Kindly comment everyone. Try to comment because this will clear the concept. Yes, perfect. Now you can clearly see that if area is increasing, so now by this logic, when area will increase, depth will decrease. Okay, yes, you are perfect. Everyone is giving the correct answer. I can see you are saying less than 15. Yes, perfect. Kiran, Manjusha, everyone. Okay, Sushil, everyone is giving the correct answer. So I think the logic is fully clear to you all. Okay. So with this note, we are going to end our class. If you have any queries, you can ask it. Okay. So I hope your studies are going fine. I hope your studies are going perfectly fine. So this is your, this is the topic of DAD curve which we have studied today. Basically today we have covered the concept of isohydral method. Okay, isohydral method concept is very clear to you. We have solved one question. Oh, wait a second. Today we have basically solved the concept of isohydral method and DAD curve. Okay, I hope DAD curve concept is very clear to you. See, these are the notes which I have to give you daily. If any concept or query you want to ask, you can ask me. Okay, you can ask the query which you want to ask, because I know many queries are there. If you want to ask, you can ask it in today's class itself. Okay, I hope you are solving, I hope you all are solving previous year questions regularly, because previous year questions will give you the boost. Okay, these are previous year questions, helps you in understanding what kind of questions have been framed in past year examination. So that basically gives boost itself. So I hope you all are solving previous year questions. Okay, so the PPT which I have to give you is ready. Okay, sir, out of 4 types of precipitation, what is the type which mainly constitutes for Indian? Yes, good question. Okay, Manjusha, great. So according to me, if you will ask, India receives monsoon kind of rainfall. See, Manjusha, let me tell you. Great question you have asked. Perfect. I will tell you the answer to this one. See, Manjusha, let me say this is your planet Earth, and on equator, I told you on equator, on daily basis, it receives huge amount of heat. So wherever you will receive huge amount of heat, uh, the land masses will get heated up, and there the air which is in the vicinity of land masses will get heated up, and they will be lighter, so they will rise. So there you will see formation of convective currents is there, and cyclone formation is also there. So near equator, or you can say near your in the tropical zone, basically you will observe convective type of precipitation and cyclonic kind of precipitation. Okay, cyclones basically generate on your oceans in your open areas where it gets huge amount of energy, and cyclones when travel from oceans to land masses, they will fade its energy. Okay, but yes, it enters and causes huge amount of destruction. But when you go near tropical zones, okay, when you cross this tropical zone or when you are near tropical zones, basically India is falling in Tropic of Cancer. You all know this. Tropic of Cancer line passes through India, so it is not very close to equator, but it is coming somewhat in the tropical region, in the above region. Now here what happens? We have Himalayan region. You all know we have Himalaya. Okay, we have Himalaya. So huge amount of moisture laden winds come up from these uh, Arabian Sea. Okay, you all know that here we have Arabian Sea, here we have Bay of Bengal, in the south we have Indian Ocean. So Arabian Sea causes huge amount of moisture to enter Indian masses. Okay, moisture, basically moisture laden winds come from both sides, Arabian Sea also and Bay of Bengal side also. And when these winds are moving on Indian continent, then you can see huge amount of mountain barriers are there. We have Vindhyachal range, we have Aravali mountain, we have Himachal mountain, Western Ghats, all kind of different mountains are there, and orographic precipitation happens. Basically, monsoon thing is orographic precipitation. So if someone asks you, basically in India, whatever rainfall is there generally happens in monsoon season only. I have already told you that variation is too much, and 50% of the precipitation which happens in the entire year happens in the 15 days only, and that is monsoon time. In monsoon time we have maximum rainfall, and that happens because of orographic nature. Okay, so all these moisture laden winds are forced to move up through Himalayan mountains, Western Ghats, all these mountains, and rainfall happens. Okay, you will see that these we can say these winds which are carrying moisture are not causing any kind of rainfall on the China side. Why? Because in that side, when these then when these winds will go to the China side, it will be completely dry, because all the winds which are carrying moisture have shed their moisture on the Indian side only. Okay, so orographic is the best answer according to me. Okay, okay, Manjusha, now I'm following PYQs. No, it is sufficient. Okay, it is sufficient, but you have to solve it rigorously. Okay, so make sure that you are solving that book consistently daily, on a daily basis, and whatever new things you are getting it there, you have to add it in your notes. Okay, this habit should be there. Okay, so I hope, Manjusha, your doubt is clear, and Sushil, I hope you are going to follow the PYQ book consistently. Okay, consistently. Okay, so great. So I like the session today. I hope you have also enjoyed it. Tomorrow we are going to discuss very beautiful topic, which is your frequency of point and fall. It will be very beautiful. Okay, so tomorrow we are going to cover that topic. It will be very good. When you will attend the lecture, you will see the beauty in it. Okay, so we'll catch up tomorrow and we'll join with the frequency of point and fall. Then till then, everyone take care, and I hope you will revise all these things before coming to class. I will also make sure that I am able to drill it into your minds. Okay, I will also revise it in the first few minutes, and then we'll proceed with the lecture. Okay, so stay blessed, take care, and we'll catch up tomorrow, and stay happy.